Hello, my dear lovely friends. How are you? I hope you are quite well and your study is going very fine. Today, we are going to discuss one another video of weak oxidizing agents, that is the chemical properties of aldehyde in ketone. And we are discussing right now the Tollen reagent, Fehling solution, Benedict solution, Schiff reagents. Okay. Students, one more weak oxidizing agent which I will discuss separately, that is the iodoform reaction, which is iodoform is also weak oxidizing agents, which I will discuss in separately with the mechanism. But first here we understand all the four, right? So let's start that first is tolerance reagents. Tolerance reagents. Students, see that how to form the tolerance reagents. There is a beaker. In the beaker we keep here that the silver nitrate and ammonium hydroxide. So in the dilute solution of silver nitrate and ammonium hydroxide, which will form that the AgNH3 all 2 OH, right? This compound will form, this is called TR, Tollen's reagents. Now, what we'll write the name? Diamine silver first hydroxide. Still, this is a complex compound. This compound is complex. So, it is a weak oxidizing agent, weak oxidizing agents, right? No, not because of complex compound, it is weak oxidizing agents. Now, see here, student, weak oxidizing agent because the electrode potential is very low. 0.8 is the electrode potential of silver. Now, what I am telling you, how to write in the how to write the reactions. See that students, when we take that AgNO3 plus 2 moles of AgNO3 plus 2 moles of ammonium hydroxide, you will get that first Ag2O silver oxide, which is a gray PPT, and plus 2 moles of ammonium nitrate and some amount of water also. Now, when the again gray silver oxide dissolve in 4 moles of ammonium hydroxide and supply little bit amount of heat, you will get that 2 moles of AgNH3 all 2 plus OH negative plus 3 moles of water, right? Student, you can see here when this is called tolerance reagent, which I have written here. Here I have written that. So in the equation manner, you can get this tolerance reagents. Now the point is that how this tolerance reagent will react with aldehyde. See, you can write in different way the tolerance reagent with the aldehyde. You can write in any way, on all the way are correct. Suppose you are writing here RCHO. Here we'll write the AgNO3 plus ammonium hydroxide, right? Then also that's correct here. That you will get that RCO negative plus Ag silver mirror will form. That is the silver mirror students. Silver mirror, you can get it here. Now you can also write exactly this equation like Ag2O silver oxide RCOO negative plus 2Ag, again silver mirror will form, means you can write this equation in a different way. Okay, all the way are correct, but I would advise to those students who are board students are watching this video, I would advise you to go write the NCRT, whatever equation is given. NCRT is given like that: RCHO plus 2Cu 2 plus or you can say that here is NCRT. See here how is written that is given 2 moles of AgNH3 all 2 plus 3 moles of OH minus. You write exactly in similar way, but competitive extent you can write in any way. Just to understand that which reagent, these reagents are tolerance reagents. So don't confuse. Only this reagent is not. We can write also in this way. So where this now this reagent, tolerance reagent will react. What will happen? That will form the RCOO negative plus 2 moles of silver mirror plus 4 moles of ammonia plus 2 moles of water. So what I would like to tell you, whenever you write these equations, you have to write all these things. Okay. So now the point is that strengths, you can see here. here is the Ag plus oxidation state plus 1, here is a 0 oxidation state. So are you observing one thing? Plus 1 to 0 is coming, that is the reduction process is going to be happen. What? There is a reduction is going to be happen. Here is a RCHO, there is a oxidation is going to be happen. There is oxidation, there is a reduction. So it is completely a redox reaction. Okay, it is completely redox reaction. Student, I am not going to balance the equations because organic reactions, there are so many byproducts. So don't bother about the balancing in the organic chemistry. Right. So compound is formed. So you can write in any way. Either you can write this way or Ag2O, or simply you can write that. Okay. Students, aliphatic as well as aromatic aldehyde both will give the tolerance test, positive tolerance test. Aliphatic and aromatic aldehyde. Aromatic aldehydes both gives tolerance, positive tolerance test. What I write here, positive tolerance test. So positive, why I am telling you positive tolerance test? Because see that some compound give the tolerance reactions, but not a silver mirror. So silver mirror means we talk about the positive tolerance test. See here, all aliphatic and aromatic aldehyde both gives all aliphatic and aromatic aldehyde gives positive tolerance test. Students, see here what I am writing here. There is a one exceptional case here. Exceptional case is alpha hydroxy ketone. See here, CH3, C double bond O, CHOH, CH. This is exceptional compound. Exceptional compound, students. When we react with the tolerance reagents, that will give the positive tolerance test. Positive tolerance test. What? That will react, that will form the diketone. Compound is going to form the diketone. So the diketone will form. So keep in mind that compound will react with the tolerance test. That will give the positive tolerance test. Students, they are so, even though formaldehyde you have, see that the formic acid, if you react with tolerance reagent, what happen? That will form the CO2. What I am telling you, student, that will form the CO2 plus H2O, right? And silver mirror, that is silver mirror. So what is formed? Silver mirror, correct? CO2 plus water plus silver mirror will form. Now your question, sir, why formic acid will give that tolerance test? Students, see that formic acid contains both the group. One group it contains the acidic group. Second, it contains the aldehyde group. So it contains the acidic group. Second, it contains the aldehyde group. Correct. So that is the reason, since contains aldehyde group, therefore it will give the tolerance test. Okay. Students, formaldehyde, what will happen? HCHO, it will give the tolerance reagent. As usual, it form the acid, and plus what happened? Silver mirror is formed. Ag silver is formed, right? 2Ag. Okay. Now what I am telling you, that the alkyne also, student, alkyne also give the silver. Not alkyne will react with the silvers tolerance reagents, but will not give the silver mirror test. See that alkyne, because alkyne contains the acidic hydrogens. See here, HC triple bond CH. It is the acidic hydrogens. So when we will break the tolerance reagent, that will give the HC triple bond C negative Ag plus. So it will give the tolerance reactions, but not give the tolerance test. So therefore, we express the positive tolerance test. So I hope you understood it. Now the point is that when we talk about the CH3, C triple bond CH, when we will react with the tolerance reagent, that also, because the acidic hydrogen is there, so it will react and form the C triple bond C negative Ag plus. Okay. Students, one thing keep in mind here, that the tolerance reagent is a strong oxidizing agent, relatively Fehling solutions and other solutions. Now I am going to discuss with you first the Fehling solutions, then you will understand here. But before that, 1-2 points I would like to add here in the tolerance test. Students, if rate of reactions, if rate of reaction of tolerance reaction means tolerance reagent react with aldehyde, if rate of reaction is very slow, or vessel, wall of the vessel or wall of the test tube. If the wall of the vessel or test tube, whatever you can say, if the wall of the vessel or test tube is clean, then you will get that metallic silver on the test tube, or metallic silver on the wall of the test tube, you will get that. Okay, what I'm telling you, if rate of reaction is very slow, either the rate of reaction is very slow or wall of the vessel is clean, then metallic silver on the wall of the test tube, you will get that. That means a silver mirror, you will get that. Silver mirror, you will get that. If wall of the vessel is not clean, then you will get that gray to black PPT. Okay, understood? If either the rate of reaction is fast, or vessel is not clean, if the rate of reaction is fast or vessel is not clean, then you will get that gray to black PPT. Okay. Okay. So I hope, student, you understood that the tolerance reagents. Now we talk about the Fehling solutions. See here. See, student, the Fehling solutions. Or Fehling test, you can say Fehling test also. See here, one beaker we have taken which contains that the copper sulfate solutions. A contains copper sulfate solutions. And student, B contains alkaline solution of sodium potassium tartrate. So when the both A and B combined, then you will get that Fehling solutions. You will get that Fehling solution. Correct? Now first we understand here. Just understand, there is no need to memorize these whole things. Directly you keep in mind the Fehling solutions. So just for better understanding, I'm going to write here. See here that first you have taken the copper sulfate, which will react with that 2 moles of sodium hydroxide. Then you will get that CuOH, all 2 copper hydroxide plus Na2SO4, sodium sulfate. Now next is that when the copper hydroxide react with the rock salt or sodium potassium tartrate, that the CHOH, COONA and CHOH, COOK. This is called rock salt or sodium potassium tartrate. So what is going to be happen here, students? That things will happen that CuOCH, OCH, COONA and COOK, you can get that. Correct? So these things you will obtain here. CuOCH, OCH, COONA, COOK. This is called a Fehling solution, which is a deep blue color. Deep blue color solution. Okay. Now exactly this solution, how to write it is very, very complex. So simply we write here RCHO plus CuOH whole 2 plus here with 2 moles plus sodium hydroxide. 2 moles of copper hydroxide plus sodium hydroxide and supply the amount of heat. We'll get that RCOO negative plus Cu2O plus water. 2 moles or 3 moles of water you will get that. Okay. So you can observe here students, or simply we can write, which is given in the NCERT, RCHO, that the 2 moles of Cu2 plus 5 moles of OH minus, and we supply the heat, then we'll get the RCO minus plus Cu2O plus 3 moles of water. See what is going to be happen. Actually, in whole the process, you observe that RCHO which converted to acid, that is the, of course, oxidation will happen. Correct. But in this case, here is the copper Cu2O which converted into here is that you will get that CuO, you will get that Cu2O, means cupric oxide, you will get the cuprous oxide, correct? So what I am telling you, students, the cupric oxide which is converted into cuprous oxide, correct? So that is the +2 oxidation state will convert to +1 oxidation state. Done or not? So here is again just like the tolerance reagent, you will get the same. Here reduction is going to be happen. Not only reductions will happen, there is color is blue. Blue, you will get the, here is a red brown, red brown, red brown PPT you will get that. So this is that Fehling solutions. How Fehling solution will work. Okay, now the interesting fact is that Fehling solution only will react with the aliphatic aldehyde. Fehling solution will react with, will give Fehling solution, Fehling test means not a Fehling solution. I write here Fehling test. Fehling test 2 only gives only aliphatic aldehyde. More precisely, if I would like to tell you, then we can say that only alpha hydrogen aldehyde. Only alpha hydrogen aldehyde. It is exceptional here. Formaldehyde which does not contains the alpha hydrogen. Despite being, it will give the Fehling test because there is a formaldehyde is more reactive. But students, you can see here, benzaldehyde or pivaldehyde. Here I write here, this is a common name, pivaldehyde. This compound will not give the Fehling test because no alpha hydrogen is there. No alpha hydrogen there. So these two compounds will not give the Fehling test because the Fehling concept, Fehling test is based on the single electron charge mechanism based, single electron charge transfer mechanism based concept. I'm not going to discuss here that the mechanism because otherwise the whole video lecture will be very boring. Simply understand that those compound which does not have alpha hydrogen will not give the Fehling test. Okay, but logic is that why the Tollen's reagent is more strong oxidizing agent than the Fehling solution because benzaldehyde will give the Tollen's test but not give the Fehling solution, Fehling test. Why? Student, you can see here when we talk about E0 electrode potential of Ag plus to Ag, that is 0.80 volt. And when we talk about Fehling copper Cu2 plus 2, copper potential is 0.18 volt. So you can see here there is a high value, and you, as you know from the electrochemistry, so compound which have high positive value is good oxidizing agents, and the compound which have a low means more negative value which is good reducing agent. So of course this reagent is a strong oxidizing agent as compared to the copper. So I hope you understood the Tollen's reagent, how you can say that Tollen's reagent is a strong oxidizing agent than the Fehling solutions. You can see that electrode potential. Okay. Now the point is why benzaldehyde will give the Tollen's test, not a Fehling solution. See here. Students, benzaldehyde, here is the compound benzaldehyde which contains C double bond OH. You know this group is the minus R effect, or you can say the mesomeric effect, minus R effect. So benzene has a lot of high electron, which can the CHO group pull the electrons, and the pull the electrons. As a result, what happened? The resonance, the completely resonance will come. So I'm not going to draw the resonance of all the structure. Just you will, and I hope you will understand here. Simply, I draw the structure here, O negative H. Okay, I haven't drawn here all the resonating structure. Directly, I came on this structure. I brought this structure directly through the resonance. It will happen. So you can see here when the resonance will happen. See, students, what is going to be happen? There is a bond is the polarity. The polarity decreases. There is a polarity decreases. Okay, but what happen? Why polarity decreases, students? Because due to resonance, the electron density increases on the carbon. On this carbonyl, the electron density increases. So electron density increases, the CH bonds becomes stronger, because according to chemical bonding we have done that laser the polarity of a bond laser the polarity of a bond, stronger the bonds. Correct or not? Laser the polarity of a bond means laser the polarity of a bond, stronger the bonds. Laser the polarity, why will happen? Because due to the resonance, here the electron density increases. So electron density increases, I mean polarity decreases, so strength will be increases between the carbon and hydrogen bond will be very, very stronger, because then the instead of covalent is going to be the ionic bond. So the polarity is going to be the highly increases. So laser the polarity of the bonds, the stronger the bond. So now it becomes the very less polar compound substances, because electron density here what happened? Electron density increases because of the resonance. So laser the polarity of a bond, stronger the bonds. Okay. Now, or suppose if you feel the complex to understand here, simply understand here double bond. It is double bond here. So it is very, very difficult to oxidize the whole chain by the Fehling solutions. And alternatively, I told that if there is alpha hydrogen, then only oxidation will be possible. So here is no alpha hydrogens, so there is no oxidations possible by Fehling solutions. Second, I just taught you that the Fehling solutions is a why Fehling solution is weak oxidizing agent, because the electrode potential is low. So you have three things strengths. One, benzaldehyde is a weak benzaldehyde will not be oxidized by Fehling solution because there is no alpha hydrogen. Or you can say that here because of polarity decreases. Why? Because resonance happen. Due to resonance happen, the electron density increases, and according to chemical bonding, laser the polarity of a bond, stronger the bonds. Correct? So anyway, you can understand this whole concept. Okay. Now, now the point is that okay. So I hope you understood the concept of the Fehling solutions. Now we go to the reaction of the Fehling solutions. See here, students, you can write the reaction in the Fehling solutions here. Okay, we have written the reactions of Fehling solution also here. So that's our. So students, I hope you understood the Fehling solutions clearly. Nothing is remains here. Tolerance and Fehling, all the things we have discussed here. Now we go to that Benedict solutions. Okay, see here, Benedict solutions. Benedict solutions. See what the exactly as to Benedict solutions and the Fehling solutions. The work is similar. Both will have the red PPT. Both we have cuprous ions, cuprous oxide, but the reagent is different. Here is that A is the copper sulfate. A is that what? Copper sulfate, and B is that what? B, we have B is that alkaline solution of alkaline solution sodium citrate. Sodium citrate. Again, what I am telling you, there is no need to learn the whole day. What I am going to write here, just to a better understand, I am writing here. First is that what? Copper sulfate will react with that because A and B combines together, then they form the Benedict solutions. Benedict, when A and B combine together, we will get that Benedict solutions. Okay. So copper sulfate, when react with that 2 moles of sodium hydroxide, you will get that CuOH2 plus Na2SO4. Correct. Now students, see that when the copper hydroxide will react with the sodium citrate is C. Sodium citrate is CH. Here is the H. COONA. CH. OH COONA. 1, 2, 3, 4. 1, 2, 3. There is no need to write here hydrogens. Okay. So simply carbon, and one is CH2 COON. This is sodium citrate. So when sodium citrate, this is the what? Sodium citrate. So when sodium citrate react with this compound, what will form? That will form the Cu, OH, CuO, and here is that C, CH2, COONA, COONA, and CH2CONA. This is a nothing but it is a only Benedict solution. So now Benedict solutions react with RCHO. What 2 moles of Cu2 plus 5 moles of OH minus. It will give that RCO minus plus Cu2O plus 3 moles of water. Exactly same reaction will happen. Red PPT will form. Okay. So the reaction of Benedict and Fehling is just similar way. Now we talk about the Schiff reagents. Schiff reagents. Students, Schiff reagents what? Schiff reagent you have heard in that addition of ammonia derivatives of Schiff reagents. So Schiff reagent is what? Schiff reagent is dilute solution of P rose aniline hydrochloride. Okay. Actually, the color is either the pink or red. Right? Student, when this solution either you dissolve in the water or you dissolve in the H2SO3. What? Where either you can dissolve in the H2 or you can dissolve in the H2CO3. So sulfurous acid, this is a sulfurous acid. So either you dissolve in the sulfurous acid or water, you will get the magenta color. What color you will get that? Magenta color, correct? So what happened? Just to see that what the Schiff reagent is here. I write the structure. C double bond, and here is that like that, N double bond. Here I write. So you will get that double bond and HCl, and here is that. This is the Schiff reagents. Okay. So students, Schiff reagents. What happened when we pass the through Schiff reagent sulfur dioxide? Then what happened? The solution Schiff reagents becomes colorless. So it will becomes colorless. Okay. So when this Schiff reagent which becomes colorless, when you pass through the aldehyde, any aldehyde you can take, any aldehyde, then the Schiff reagent restore the color. Student, if the color is restored, means colorless to color, means Schiff reagent bring the original color through the formaldehyde. If any aldehyde put in the Schiff reagents and you get the color of Schiff reagent, that means the aldehyde is there. If you are not getting the color, that means it is not aldehyde. So it is a best way to distinguish between aldehyde and ketone. Okay. Okay, students. So I hope you understood that weak oxidizing agents. Students, all the things. If you have any doubt regarding this video lecture or any concept you have a doubt, you go in mail section, do the mail, just send the mail, and I will discuss your doubt in the next video lecture. We will discuss separately the iodoform test. That is also a weak oxidizing agent. Thank you, students. Have a nice day.